For as long as we can remember, antibiotics have been the simple, easy treatment for various illnesses and bacteria. They save millions of lives every year, and you probably have never thought about what we would do if we didn't have antibiotics. The problem isn't the question of what we would do without antibiotics, but instead it's what we do now that antibiotics have decided to evolve and turn more into a threat than an advantage. First things first, what is antibiotic resistance? Antibiotic resistance, also known as ABR, happens when bacteria change and become able to survive antibiotics, which are medicines used to kill them. This makes infections harder to treat because the usual drugs no longer work. Why should we care, or how does antibiotic resistance affect us? Antibiotic resistance is a serious global threat because common infections become harder to treat. Diseases like pneumonia, tuberculosis, and urinary tract infections may not respond to the antibiotics. Medical procedures become riskier. Surgeries, cancer treatments, and organ transplants rely on effective antibiotics to prevent infections. Also, illnesses become longer. Aubrey, do you finish your antibiotics?
Yes.
Martha, do you finish your full course of antibiotics?
I do not.
Jasmine, do you finish your full prescription of antibiotics?
Yes.
Ureli, do you finish your full prescription of antibiotics?
I do not.
Caroline, do you finish your prescription of antibiotics?
No, I don't.
So, how does antibiotic resistance start? Pathogenic bacteria develop antibiotic resistance in two main ways. One way is through spontaneous mutations that occur during chromosome replication, which can make bacteria resistant by changing the targets of antibiotics. The other way is through mobile genetic elements like plasmids and bacteriophages, which transfer ABR genes between bacteria through horizontal gene transfer, also known as HGT. This process is especially important because it allows pathogenic bacteria to gain resistance genes from harmless bacteria, making resistance spread more quickly. So let's break that down a little. Mutations are random changes in their DNA that can sometimes make them resistant. Horizontal gene transfer, also known as HGT, they can take resistance genes from other bacteria. This can happen through plasmids, which are small DNA loops that carry resistant genes and can be shared between bacteria. And bacteriophages are viruses that can infect bacteria and can transfer resistance genes. At first, ABR might make bacteria weaker. However, over time, they can evolve to overcome these weaknesses, allowing resistant bacteria to survive and spread, even when no antibiotics are around. The widespread use of low-cost pharmaceuticals, preventative treatment with broad-spectrum antibiotics, and the overuse of these drugs all play a major role in the development of bacterial drug resistance. So, how are doctors and scientists working to stop the spread of antibiotic resistance? One way doctors and scientists are working to stop the spread of antibiotic resistance is by using combinations of different antibiotics. This can help prevent bacteria from adapting too easily. Scientists are studying a concept called collateral sensitivity. This happens when bacteria become resistant to one antibiotic, but as a result become more vulnerable to another. By carefully choosing antibiotic pairs, doctors might be able to use this weakness to fight resistant bacteria. Some important resistance genes make bacteria more sensitive to certain antibiotics. Also, resistance genes carried on plasmids can change how bacteria process nutrients, which might create weaknesses we can target with specific antibiotic combinations. So, what can we do to prevent ABR? Only take antibiotics when prescribed by a doctor and always complete the full course of antibiotics even if you feel better. Stopping too soon can leave resistant bacteria behind. You can also do some of your own research about ABR to further your knowledge about this growing global medical threat. Now that I've informed Martha about ABR, Are you going to start finishing your antibiotics?
Yeah.
Now that your Ellie knows about ABR, are you going to start finishing your antibiotics?
Yes.
Now that I've informed Caroline about the risk of ABR, are you going to start finishing your antibiotics?
Yep, I am.
Thank you so much for listening about the evolution of antibiotic resistance, and keep in mind the ways you can help stop the spread of this growing threat. Next time you are prescribed antibiotics, remember what finishing the bottle can do for not only you, but the whole world. Thank you.